Hello guys, this is the second video about the character skeleton, and we said last time that from now on we're going to start working on connecting all the modules, putting everything together. So in order to do that, I need to start introducing the concept of spaces. So let's start. Spaces. So today we're going to talk about the concept of input space, local space, and world space. What are these and why? So the combination of these three things will allow us to achieve a couple of things. The first one is it will give us a interface, a nice interface, a consistent interface to connect modules together. What I mean by that is you can connect modules together, connect the head to the spine, the arm to the spine in many ways via parenting controls or doing specific thing for certain modules. But in order to make this a little bit more consistent across the board, so it's always the same procedure, it's always the same train of thoughts that you have to apply for each module. This is a way that allows you to use the same technique over and over again. So when you come to debug modules, you know where to look. And again, it's following the idea that we're trying to make something modular that can be reused all over the places. So having a consistent interface that allows us to do that, it's nice. So this is the first thing that these three things allows us to do. And the second thing is going to allow us to add features almost for free. Features to the modules. Okay, so when you're working just with a head, you set up certain features. All right, you have the neck, the jaw, the head moving, the spline IK, the FK. That's what we saw. When you work with the spine on its own, you add the rib cage, the bendy, the whatever you can think of. We've seen that kind of features. But the truth is that when you work locally on each module, you of course you implement the feature specifically for this module. But when two modules are connected together, let's do it this way. When two modules are connected together, it's also true that between these two modules, you can add specific features that are related to that connection. Okay. Today we're gonna see. Let's start by analyzing just let's give an example of what these features are when we are connecting. Let's start with the head and the spine. So over here. So what kind of features can we add when two modules are connected together? And this is true for every module, by the way. This is something you can decide. So there are certain modules that when connected together, they still act on their own. Absolutely. I'm not saying that every single couple of modules needs to have this implemented. But for a biped, there are certain features that are nice to add for the animator. So what does it mean adding features to the modules when they are connected? So in this rig, which is, it's exactly where we left. I only added a couple of things in order to start this class. This rig right now, if you check the graph, it's disconnected. Arms and legs are disconnected. These are legs and arms. Legs, arms, legs, arms. Setup mode, setup solver, and forward solver. Okay. So only the head and the spine are connected, as well as the eyes, but I'm asking you for now to ignore the eyes, and we're not going to talk about eyes today. So if I move the rib cage now, you can see that the head is moving with it. It's not disconnected like we saw last time. So the two modules are somehow connected. But one of the features that we can add in order to help animation out, in order to do certain things and certain type of animation. Now, I want you to imagine that the animation that we're doing, it somehow is this chest rotating around, okay? So it's doing some sort of dance. And if we want to keep, you can see that now the head is rotating exactly with the rib cage, and this is kind of expected. But what happens if we want to keep the head kind of in the center like that? Okay, you can see that now because the two modules are connected and the way these are connected, the head still follows. So the animator, in order to preserve the position of the head, to have like a Steadicam kind of motion, to have like a head staying really still in the center, from the neck up. Well, this is one of the features that having input space, local space, and wall space will help with. If I select this control here, this settings. Oh, we're gonna look all of this, by the way, so don't worry. This is just to. You can see that by changing the one setting, the head space, you can see that the head behaves differently. Okay, so I'm turning this off, and what this gives now is the ability to have the head with a nice orientation, meaning that the head always stay. Let me rotate this thing. You can see that the eye module are working. They're always looking at this thing, but we're not going to talk about that today. So you can see that the head now doesn't have to be counter animated. Okay, so what's happening here in reality is that when this option is on, when this option is off, when this option is false, the neck module is only using the translation of something. Okay, and if I turn on the bones, effectively this neck here, the entire module, is following the translation, and translation only, of whatever I've specified as an input space. So to introduce the concept of input space, the input space is a transform, it's a space that drives, that is the driver of a module. Okay, so you can see now that the neck is connected, the neck module, the head module is connected to the body, but only in translation. So it's following the position of the input space, which we're going to see what it is now, but only in translation. If I turn this on, now it's following both translation and the overall rotation of the input space, as if it was parented to it. Okay, so let's have a look. It looks like now the neck and the head are completely parented underneath. I'm taking my time just to show this back and forth, and I'm aware that this is going very slow, but this is how it is. So this is just translation. So the orientation, somehow this neck module is oriented, but not oriented against the rib cage, is oriented to something else. Okay, and this is where these two things now come into play, 1 and 2. So how is this all achieved? Let's have a look at the module of the head. this is exactly the same module of the head that we left, but I added two more things. The input space, the local space, the world space, so these three, and then the toggle, the input orient, meaning that do we want the space, the orient to follow whatever is in input space, or do we want to follow something else? This is how you read it. The input space, neck input space, is basically the transform that you want this module to follow, both in translation and rotation. The input orient, it's a toggle, it's a true or false, where you say, if all of these, if the input orient is true, completely follow the local space driven by the input space. Okay, so let's try this. So input space is nothing else than a bone. Okay, in this case it's nothing else than usually a bone or a transform. Cool. This bone is driving the local space of the module in translation and rotation. Okay, so the input space, something that is worth mentioning. Input space is usually, well, actually 99% of the time, outside of the module. So the input space represents the connection. So if I have a head here, a head module, and a spine module here, 99% of the time, the input space for the head, so input space, is something that lives or exists outside its domain. In this case, spine 11 is the input space of my module head. So spine 11 is this bone here, and this bone here position defines how the neck is moving. Okay. Now let's jump into the module head. So this module is identical. The only thing I've added is I've parented everything that we left. So the only controls that were left in the head module underneath something that is called local space. And then I'm snapping the local space to the neck. And this is simply to put the local space exactly at the base of where the neck was. So nothing fancy. And this is something that is happening here. Then I have another group here that is called wall spaces. This group here, it's only for organization. It doesn't mean anything. This is a group at the origin, and it's hidden, and it doesn't have any shape. This is just a group. Basically, this is just visualization purposes. Inside this group, I have a neck world space. So you have a neck local space and a neck world space. The neck world space is aligned to the base of the neck as well. So if I go into the rig graph and add drop transform here, and I now take the local space, get transform, and I draw it, you can see now these axes. So the neck local space It's a line at the base of the neck. Let me do that again. But this time, instead of neck local space, I use neck world space. At this very moment, the two things are on top of one another. Okay? If I were to move now this, you can see that the neck follows. The local space follows. The world space stays like that. Okay? Which gives me the, if you notice now, if I put it in front, sorry, I'm just trying to be very slow and careful in what I'm saying, and just so I can show you and be really precise on what I'm saying. You can see now that the neck, it's vertical and it's oriented in a certain way. Okay? If I were to put this now into settings, if I go into settings and change the neck space, you can see now that the neck space is now oriented like that. So the neck space, local space, is the group above everything that drives my neck. Okay? So if we go back in here and we start, let me get rid of this thing. Let's move it down here. So if I now, considering what I've just said, I now have a world space that drives on or off based on a branch the rotation of the local space. So the local space is nothing else than a group above the controls of the modules, and it's driven either completely by the bone in both translation and rotation, or if this branch node is false or true, its rotation is driven by the world space. And we can see this here. So in this case, with these settings, the local space, it's oriented exactly in translation and rotation like the input space, which is my bone. So effectively what it means is that the neck and the head module are parented. You know, they are behaving like as if they were children of this guy. If I turn the settings off, the neck is now following the bone input space, but it is oriented like something that I'm never rotating. So you can see that the rotation is exactly like this one. Last thing to add is one little observation, is that compared to the previous rig, there is an additional difference that I've added these two controls, global and global offset, these two circles. These are meant to be there in order to place the characters around and provide an offset from the placement. So you can position this guy and rotate this guy. Okay. Now I want you to have a look at what's going on here. Okay, because this is where, and is the reasoning behind you want to build a common interface between modules and a way to connect them. So if I take this guy and rotate it, you can see that the neck, everything in the body, well, of course, all the other modules are disconnected. So the arms are following because they are children of this thing, but we're going to slowly connect all of them. If I rotate this guy now, you can see that the neck is following and the rib cage is following as if they were children, right? if I take this thing now and rotate it, you can see that this object here is still oriented like the world space of the neck. And this is because the world space of the neck, it's itself parented underneath this object here. So this is the other difference. So in the end, what I will have is a global control, a global offset control, and then this, as I said, these are just spaces. Inside here, there is this neck world space, is this object here, and a follow is basically children of that. And what this gives me is the ability to offset everything. I don't want this behavior to happen relative to the world completely, but rather relative to the main global world. This big circle, it's meant to be the main global world. All right, so it doesn't matter if, you know, if this object, it's children of it, this behavior here should still reflect this orientation. Okay, so let's have a look at the mod. I hope this makes sense. It's a fairly, I know it's a bit of a it looks like a complicated concept. It's actually harder to explain it rather than actually implement it. And we're gonna retouch it again when we do the other module. So bear with me on this specific concept. So let's have a look at the module of the head real quick compared to the previous one. As I said, I'm simply snapping the local space and the input space into at the base of the neck, and then at the very end, I'm checking, does the user want the head to be oriented? Yes or no? So I have a branch, and the branch is saying, if it's true, get the space, the neck local space, get the input space, and get the input space, connect, project to new parent, so parent constrain the input space completely to the local space. And what this means is this: we are in this scenario where the input space drives completely translation and rotation, so it acts like a parent. Instead, if it's false, I only take the translation out of it. So we are in this case. So the input space drives the translation. And the world space drives the rotation. So in combination, now we are here. So the final position of the local space is driven either by its input space completely, or the rotation is done using the world space instead. So this is the only difference that happened in the module. Basically, this area here to drive it, and this area here to place it. So this is the setup mode, where I'm snapping the two objects, the two spaces, the local space and the world space. And this is where I'm driving them. Okay. I hope this makes sense, and we're gonna come back to this. But this is the first. This is, to me, this is really important. These concepts here. Okay. Thank you.